Let's work on the integral with a weird long square root shape. So the formula below is the one we're going to be using for this integral. We need a shape of the integral that looks like integral of square root number squared minus input squared. We have number minus 4x minus 4x squared. That is not convenient at all, so I will try to work with my 6 minus 4x minus 4x squared separately to figure out the shape we want. And we would want to complete this square in this situation. Do you guys remember how to complete this square or not? Don't touch the 6 yet, just let's factor out minus 4. Minus 4 will give me x squared plus x, and then plus 6 is a constant standing outside. Now, from this piece, x squared plus x, I want to create a full square. So minus 4 is still standing outside, and inside I will have still x squared plus x, and I need to think what do you need to add and to subtract to get a full square. Now the full square is a, let's not use a since we're using a here, let's do y squared plus 2ym plus m squared. That is my y plus m squared, square of sum. Such a weird choice of variables, but whatever. So we have x squared, nice. Now we have x, let's call it y in this case. 2 and m are missing, so I'm going to divide by 2, but then also remember that I need to square it. So let's see what's going to happen if I'm going to add and subtract 1/4. If this is good enough or not. So by good enough, I mean, is this going to make me a square root, x squared plus x plus 1/4? That's my question. If this is going to be enough to have a full squared. Well, it is. This is going to be x plus 1/2 squared. Let's check. X plus 1/2 squared is the square root of the first term, which is x squared, plus double product 2x times 1/2 is 1x, plus 1/4, because that's 1/2 squared. Works, that's exactly what we had here. So that's how you complete the square. You need to know which parts are missing to have a complete square. Now, what about those pieces? We still have minus 4, but not just minus 4. Not just minus 1/4. Minus 1/4 is multiplied by by negative 4. And also there's a plus 6 at the end. So let's collect those terms. I will have minus 4 still multiplied by negative 1/4, and there's plus 6 at the end. Simplify the constant, and you will get minus 4x plus 1/2 squared. That's my full square that I figured out. And then I have minus 4 and minus 1/4 gives you plus 1. Plus 1 plus 6 gives you plus 7. So that's my new form of whatever was inside of the square root. So my integral actually looks like this. This is the integral. So I need the shape input squared. No, I need the shape constant squared minus input squared. That's why let me write down this as 7 goes first, minus 4x plus 1/2 squared inside of the square root dx. So this is what we did. We created a full square. Still doesn't really look like whatever we need, but we can always create a number squared out of anything. So if we have 7, how to create a square out of 7? We'll put a square root of 7 and then square it. So here you go. Now we know that a should be square root of 7. A is square root of 7, as you can see. Now, what about the other part? The other part can be written as one piece if I'm putting in my negative 4, right? So I don't like that this minus 4 is outside. Or I would say 4. 4 is not convenient to have outside. So let's put it inside. Or I can just see that 4 is 2 squared. That actually also works. So I will write it down like so. It's going to be integral, and it's going to be the square root of 7 squared minus 2 multiplied by x plus 1/2, and everything is squared, dx. Does this make sense? So now I know that clearly u, which should be squared, is all this piece here. This is my u, and this is my a. Perfect. And I also can actually multiply by 2 everything, so it's going to be 2x plus 1. Yeah, I don't have to have it so complicated. So if a is square root of 7, and then u is 2x plus 1/2, or let's just multiply by 2, 2x plus 1, then let's also find du. Du will be just 2 dx. All this will be good enough to convert from the integral we have into the integral we know, because now the integral we have, equal sign, becomes, let's see, integral of, so we're going to have a huge square root. This is going to be a squared minus u squared, but dx should be found. Dx is du over 2. That's why it becomes a square root of 7, that's a squared, minus u squared, right? And du, or I mean dx. dx is going to be du over 2. du over 2. That's just 1/2 in front of the integral. So it is 1/2 a square root integral 7 minus u squared du. And that's perfectly what we have over here in the formula. The formula tells me that it's going to be 1/2 in front of everything, but we already have 1/2. So I'm going to put it like so, open the brackets, and now use the formula. 1/2 u, keep in mind what is my u, or if you want, you can slowly write down first with u and then unfold everything. I don't like doing that. I see it's u over here, so let's write it down. U is 2x plus 1, so what's the problem to write down 2x plus 1 right away, right? 1/2 u, we did this. Now, there's a square root. A squared, a is square root of 7, so a squared will be just 7, minus u squared. It's going to be 2x plus 1 squared, plus 1/2 a squared, that is 7 again, and it's going to be arc sine, which is sine minus 1, u over a. U is 2x plus 1 over a, which is over square root of 7, plus c. That is the answer. Don't forget to close the brackets, for example, here. You don't have to close brackets over here, because c absorbs 1/2. But now we can simplify by multiplying everything by 1/2 and so on and so on. So it's going to be 2x plus 1 over 4. 1/2 times 1/2 is 1/4. A huge square root. Now you can actually simplify it back if you want into the original thing, which is 6 minus 4x minus 4x squared. That's not necessary, but this is what we started with, if you remember. It's the same thing as in this green box, so we can kind of bring it back, but you can keep it as this shape and this form, 7 minus square of 2x plus 1. Then we have plus 7 over 2, arc sine of 2x plus 1 over a square root of 7 plus c. And that is the answer. That's a nice example where we need to use an integral from the table to find the integral we're working with. But the intermediate steps were kind of stuff what we teach in algebra classes, where we need to create full squared, complete the squared, right? Let me write down for you, complete the square. So we completed the square inside of the radical or the square root. We'll Well, hopefully now you know that this problem was tedious mostly because of the small details from algebra. But other than this, it's always important to choose your A, your U, find the U, and just carefully plug everything in and get the answer. Thank you for watching.